Pegasus is an open-source workflow management system funded by the National Science Foundation. It provides end-to-end workflow execution, monitoring, and debugging capabilities. Pegasus has been developed with the needs of scientists and researchers in mind. With its intuitive workflow API and tried-and-true planning engine, scientists can turn their research experiments into large-scale workflows, ready to be executed at scale on modern distributed systems. Now say that you, a scientist, a researcher, or student, have set out to answer the hardest questions at the bleeding edge of your field. You've developed a series of computationally intensive experiments, but are held back by limitations such as compute power, storage capacity, and deadlines to produce results. In this situation, you direct more resources towards a problem, whether it be cloud resources, HD-Condor pools, high-performance clusters, or a mix of both. This is where Pegasus can provide the tools you need to get the job done. The first step is to define your experiment as a workflow using one of the Python, Java, or R APIs. Here, using the Python API, you would define your workflow in terms of each compute job, that is, the executable that will be run, the input files required, and the output files produced. Pegasus will automatically infer dependencies between jobs based on the input and output files used for each job. And finally, each job itself may be a sub-workflow, allowing you to organize larger workflows on the order of hundreds, thousands, or even millions of tasks. Once you've defined your experiment as a Pegasus workflow, Pegasus will compile your abstract workflow into an executable one, specific to the execution environment you are targeting. This is referred to as a planning phase. Because Pegasus workflows are abstract, they are also portable, as they can be planned to run on different execution environments as the infrastructure available to you evolves. Here, jobs are mapped into the compute resources available in your execution environment. In Pegasus, workflows are represented as directed acyclic graphs, and by utilizing the wealth of research done in graph algorithms, during this planning phase, Pegasus is able to perform optimizations to the workflow to improve its reliability and scalability. With an executable workflow now generated, you are ready to begin the execution of your experiment. Pegasus is built on top of HD-Condor and heavily utilizes HD-Condor Dagman as its execution engine. Once your workflow is up and running, Pegasus will handle the movement of data between a staging location and the location where the jobs run. A large number of file transfer protocols are supported, such as HTTP, S3, and STASHTP to name a few. Pegasus provides you with the tools, both command line and web-based, to monitor the progress of the workflow and debug any failures if they occur via detailed reports. You can even set up your own custom monitoring and data collection solution, as Pegasus can emit workflow events over AMQP as they occur in real time. Improvements to Pegasus over the years have been driven by a diverse community of users spanning a myriad of fields such as physics, astronomy, seismology, and more recently, machine learning and artificial intelligence. In practice, we've seen Pegasus being used to power scientific experiments that detect gravitational waves between colliding black holes, generate science-grade mosaics of the sky using thousands of images, and run wind speed algorithms using radar data to produce weather maps. The Pegasus team actively communicates directly with its users to provide support for developing and running workflows, advocate cyber infrastructure best practices, and holds regular online office hours to apprise the community of new developments within the project. The Pegasus project is committed to accelerating research across all fields of study through the efficient use of distributed computing environments, and will continue to develop effective workflow execution techniques as these computing environments evolve over time. If you would like to learn more about the Pegasus project, check us out at pegasus.isi.edu.